All right, here we are getting kicked off with Unit 2. And just so you know, Unit 2 is the nuts and bolts of geometry. Okay? Geometry is all about logic and proofs. Okay? And a lot of what we will cover in geometry is what you'll need to put into your problem solving um, box to help you with problem solving. There is so much in geometry that's non-math related to help you in the real world. And Unit 2, like I said, is the nuts and bolts of that. Okay? So, let's go ahead and get started. Remember to be putting your course and section number on all communication. I've gotten a lot of good response to this. A lot of course numbers and section numbers. I'm telling you, it lets me help you so much faster if I have that information. Okay, the objectives in 2.01. Y'all know I got to get my pointer. I like my little pointer finger. Define and identify tools for informal reasoning such as observation, measurement, and experimentation, and describe the properties of proofs. Here's some new terms that we're going to be going over. Deductive reasoning. That's a type of reasoning that uses previously proven or accepted properties to reach a conclusion. That's the main kind of reasoning that we will be using in geometry, although we do use a little bit of inductive reasoning. That's a type of reasoning that is based on observations of patterns and past events. Now, what is an observation? That's an act of seeing or otherwise recognizing a situation, detail, or the like. And then we have our premise. That's a statement that is presumed to be true in the course of a logical argument. See, this sounds like a lot like a court of law, okay? And that's exactly what we are. We're the lawyers, and we're proving things. Okay, the proof is a clear, logical structure of reasoning that begins from accepted ideas and proceeds through logic to reach a conclusion. Any of you Star Trek fans out there, you will feel like a Vulcan whenever we get finished with Unit 2. I am a Star Trek fan. Okay, let's get kicked off with inductive reasoning. And I've kind of already read the definition to you, but there it is again. Now, when you use inductive reasoning, you draw a general conclusion from specific observations, experiments, or measurements. We also, in layman terms, can consider inductive reasoning making an educated guess based on a bunch of specific examples. And whenever you're using inductive reasoning, you're always going from a specific to a general. And I promise you, all this is going to make a lot more sense when we get deeper into this. Deductive reasoning, there's the definition again for you. Deductive reasoning is used in mathematical proofs. It's also the valid way to draw conclusions in mathematics. Now, with deductive reasoning, we're always taking general ideas and making them specific. Okay? Here's the definition of a premise. And this is the statement we start with in proofs. It's usually a given. It's information that is already given to you. Okay? And also the premise that's given to you, we could also call that like the inductive thought, the educated guess. But we have to use deductive reasoning to prove it true. Now here's the properties of a proof. You're going to begin with true premises and use deductive reasoning to reach a valid conclusion. Okay? You're going to begin with some true premises and you're going to use deductive reasoning to reach a valid conclusion. I like this little clip that I saw in the LMS. Valid premises plus sound logic equals proven result. Now let's look at some examples. There wasn't much to lesson 2.01, by the way. Identify the premises and conclusion of each statement. And here's the statement. It says a figure is a rectangle when it is exactly 90, when it has exactly 4 90-degree angles. Okay, so you have to figure out what is the premise and the conclusion. The premise is a figure has exactly 4 90-degree angles. See, here's your premise. It has exactly 4 90-degree angles. Your conclusion says it is a rectangle. And that sounds good. I like it. Here's another statement. The product of a negative number and a positive number is a negative number. So let's look at the answer. The premise is the product of a negative number and a positive number, and the conclusion is it is a negative number. So you're taking an idea, okay, and then you're making a conclusion based on that idea. This instruction says identify the premises and the conclusion and then determine whether the argument is valid and explain why or why not. It says while on a boat trip, Johnny sees a whale. Because the whale is swimming in the ocean and all things that swim in the ocean are fish, Johnny tells his mother that the whale is a fish. Okay, we're going to answer part A first. The premise is a whale is swimming in the ocean. Another premise is all things that swim in the ocean are fish. And the conclusion is a whale is a fish. Now we have to determine whether the argument is valid and explain why or why not. It is not a valid argument because the premise, all things that swim in the ocean are fish, is not true, because we all know that mammals swim in the ocean as well, of which the whale is one of. Okay? So look at this. A whale, if you read the statement again, Johnny sees a whale. Because the whale is swimming in the ocean and all things that swim in the ocean are fish is our premise. The whale is a fish is the conclusion, and it is not valid. Here's a geometry example. The angles of triangle DFG are congruent to the angles of triangle PZT. Because similar triangles have congruent angles, I hope I'm saying this right, Dimitri says that triangle DFG and triangle PZT are similar triangles. Okay, I'm going to look at A first and identify the premises. It says, well, let me look at the answer. I'm getting ahead of myself. Similar triangles have congruent angles. These similar triangles have congruent angles. Okay. The other premise is that the angles of DFG and are congruent to the angles of triangle PZT. I was starting off with that one, and I knew they were funny and did it a little different. They flip-flopped them. It really doesn't matter which premise comes first right now. The conclusion is that they are similar triangles. Now this is a valid argument because triangle DFG and triangle PZT meet the criteria to be defined as similar triangles based on the first true premise. Now then, what you need to be doing today is reading through the LMS lesson and completing the study guide if you haven't already. Read through the pages 33 through 35 in the reference guide. Complete the following problems in the problem set. It's just a few, 1 through 11 odd. I think that works out to 5. Please contact me or attend TOGA if you have any questions before completing the 2.01 quiz. And then make note of any general questions you may have when you attend CC on Thursday. And we'll talk to you later. Thanks for listening.